So good morning, everyone. And I would like to thank each and every one of you for being here today with us. Today marks our inaugural Data Yap conference, and we are proud to be able to host it today here in this wonderful virtual place with you all and Yap about data. Before we get started, I would like to express my sincere appreciation to all of you who generously helped us to make this event come together and to become a success. All the speakers and moderators, the planning team, and of course, our sponsors, the Chicago R User Group, Femilab, Elastic, Econos Analytics, and Lawrence Livermore National Laboratory. We couldn't have done it without you. In today's gathering, we plan on yapping about data quite a bit to celebrate the soft launch of Data Yap, a knowledge platform for all things data. Our mission is to provide a data resource and community center with crowdsourced content ranging from data engineering, data collection, preparation, integration, analytics, visualization, and strategy. Everyone here has chosen to support this mission. Your passions help us all to unite, and the energy we create is what allows us to achieve our individual as well as group goals to drive this vision. During this month, we will be bringing in more users on a rolling basis onto the Data App platform and invite everyone here to please sign up to be notified when there's allowance to access the platform at datayap.com. Well, I don't want to take up too much of your time, and I need to leave some time uh, for the fantastic keynote speech that's coming up. Today will be fun and full of learning and networking. So, very warm welcome to each and every one of you. If you have any questions, suggestions, clarifications, or just want to say hi, you can ping me and the rest of the team in the community section of the virtual conference platform. Thank you very much for listening, and let us welcome our keynote, who will tell us about intelligent data understanding for smarter AI. So a bit about Dr. Borne. Dr. Borne is a data scientist and top worldwide data science influencer. He's a career data professional, a data science leader, a research scientist with background in astrophysics. Previously, Dr. Borne was a professor of astrophysics and computational science at George Mason University. Before that, he spent 20 years supporting data systems activities for NASA space science missions, including roles with the Hubble Space Telescope and NASA Space Data Operations Office. He earned his PhD in astronomy from the California Institute of Technology. Welcome, Kirk.
Thank you, Mechi. So great to be here. Appreciate this opportunity. I'm going to share my screen and hopefully that'll work. But before I do that, I just want to say I love data. Hopefully you can see that little logo on my slide there. But also I just want to announce that as of this past week, so announced on Monday, my new role at Data Prime. This is a startup which is building a platform to help data scientists looking for new opportunities, new job opportunities, new career opportunities, to match their skills and talents uniquely and personalized to particular jobs that companies have out there. And so it's basically a match.com for data professionals and data professional jobs. All right, so data professionals are not just data scientists, they're data engineers, data analysts, dashboard specialists, visualization specialists, you name it. You're a data professional. Check us out. You'll see a link in my slides there, and we're actually asking people to enter their profiles because that matching algorithm will work best the more people we have in there. So it's free for you to enter your profile. So I hope you go there. So that's a little bit about me. I just started that position this past week as their chief science officer. Okay, so I need to have screen share, I believe. Let's see.
You should have screen share rights, I think.
It says host has disabled participant screen sharing.
Oh, oversight. Let's work and rectify that right away.
Right.
Mm.
Well, while you're checking that, let me just keep talking, and then you can wave at me when when it's ready. But the presentation today, you can't see the title slide, but the presentation is about intelligent data understanding for smarter AI. And you'll find out what I mean by both of those terms, intelligent data understanding and smarter AI. Of course, it sounds sort of trite, but it's actually a very critical thing that we need to do with our data. And the reason this is important for AI is because AI consumes a lot of data, and it's not just consumes it, it devours a lot of data. So let me ask a question here while we're getting the screen share working. It says I'm a participant. I must have been on, I should be on as a speaker, but that didn't seem to, can't hear you.
Oh, sorry, Kirk, did you log in with the Zoom link or through you probably logged in through the app as
And I logged in through the Zoom link, actually.
Zoom link. Okay, all right. Let's see.
Does she want me to drop out and come
All
back?
right, you're good.
Wow, there you go. Excellent.
Yes.
Thank you so much.
Okay.
And I'm going to go to full screen share. Hopefully you'll see all that now. Are you seeing my first slide?
Yes, we are.
Very good. Okay, well, I will continue. Thank you very much. Again, intelligent data understanding for smarter AI. That's what we're talking about here. And so as I was just saying, AI devours data. We get actionable intelligence from many diverse data sources, and just a few are listed there. Sales data, industry data, machine data, asset performance data, customer data, purchase histories, and so forth. We just get data from everywhere. And the benefits of AI go hand in hand. It correlates, the more impact it has when you have more data, more complex, not just complex data, but different contexts of data. That is not just one stream of one type of data, but many different types, because that gives you that context that defines human intelligence. So human intelligence, a cognitive human, isn't just looking straight ahead at one narrow thing. They're taking in all the context in a situation. So an actionable intelligence, which AI should be, not artificial, it should be an AI actionable intelligence, is deriving its context and decision inputs from all these contextual data sources. So I saw this quote recently from Jeff Bezos, whom many of you know, and he said that 5 words that people don't think about, especially in business, these very simple 5 words: create more than you consume. So you can create, if you're creating more value than the value that you're consuming, then you are going to be successful. Now, this makes a lot of sense in business. Of course, you want to have a net revenue in your business, right? You want more profits than the money you spend, your expenses. But in life in general, you want to give back. You want to be, your relationships will be richer if it's not just you taking, but also giving. But also in business, not just money, but in terms of customers. If you create value for your customer, not just for yourself, that is just consuming things that make value for yourself, then you're going to be a much more successful company. And so if you read this article, which is linked there, he says that even though this guy is like the richest guy in the world, right? He's worth $200 billion, which is an enormous amount of money. But he says that the value of Amazon is 1.4 trillion. And the difference between what his value, which is a lot, of course, that difference is still 1.2 trillion. And that value is held by by people who are shareholders, right? People who have 401k plans and investments in his business. He has created value for other people to the tune of over $1 trillion. So if you create more than you consume, you'll be very successful. Well, with our data, it's the same way, because data is reusable. And that is, if we're trying to create value from data, we don't just want to consume the data and use it once. If we can take in that data, we can reuse the same data over and over and over again. So people sometimes say data is the new oil, and I think that's ridiculous, because oil is not expendable. It's not renewable. Once you use it, it's done. But the same data set can be used multiple times. For example, you may have data on your customers and for example, purchase histories. Then if you're just using that just, for example, to build a recommender engine, which is great, but you also can use that data to create market trends, to predict market trends, to see what other kinds of things people are buying based upon things that are happening in the world. Maybe it's economic related, or some sporting event, or some other type of contextual information. Maybe even during with the weather, people's purchase patterns may change. So looking at other contextual data brings more value from that original thing that you maybe only used in one particular way. And so you can create new products and new services by reusing data. So using the same data over and over again, you're creating more value. And the way you create that value is what I call using reusable smart data. That is, you can create value by making that data not only accessible, but in the first place, find it searchable. Can you actually search and find the data that you need for that next business case? You may have used some particular data for one business case, but how do you find it again? How do you find the relevant piece of data, or groups of data, if you do want to use it in another application? And the way you do that is to tag, annotate, and store those annotations, store those tags. And I'm going to say later on near the end of the talk that one of the best ways to collect and store that and to search for it again is in a graph database. So if you think about tagging and annotating data, it's basically adding context to the bits and the bytes that you're collecting. So it's not just about the bits and bytes. It's when was it taken? In what context was it used? In what context was it taken? Who used it? Which business applications use that data? So if you can find out all these different things about that particular piece of data, then the next time you need to do something similar to that, it should be searchable in a database, not just for the bytes, but again, these contextual metadata, which are these tags and annotations. So one way to think about this AI thing, which is consuming, or as I said earlier, devouring data, think about a self-driving car. A self-driving car, much like this example sort of illustrated here in this animation, it's got cameras, it's got LiDAR, it's got radar, it's got a lot of different sensors, and it's collecting information so that it would navigate safely in this environment. And so it's tagging things, cars, people, stoplights, stop signs, traffic regulations, all kinds of different things are in that environment, and it's tagging those things in order for it to make a smart decision, next best action based upon that information. But imagine collecting that information, not just using it in that moment, but collecting that information to say, what's the foot traffic in this neighborhood and around these stores and at this particular times of day? That actually creates more value because you understand what's going on in that environment on particular days of the week, particular times of day, and so forth. And so you can actually start looking at sort of trends, maybe even just watching what people are wearing. It tells you something about the weather. It tells you something about clothing trends. There's all kinds of market value, if not for your own business, even for other businesses. So by creating these tags and curating it and making it searchable, you now have smart data, and that therefore you have intelligent data understanding. That is, you now understand what your data is meaning is, and you can reuse it. So one of the cool applications of computer vision here is that it's actually being used for video content labeling. So computer vision is what you see animated here, that it's actually labeling the things in the environment to help the car navigate safely. But once you annotate that, store those annotations, then you can actually search for video, search for even like a scene in a video, a particular time stamp in the video where show me a video where a blue car passed a yellow taxi. Well, there's one there. Okay, so if you can start searching videos, not just in the cities, but in the world, people who are capturing video of sporting events, their vacations in the mountains or on the beach or wherever, you can start searching videos by content because those labels are extracted by the AI. It's labeling and making it searchable again and reusable again, therefore creating more value beyond the initial application. So AI's big challenge then is how do you deal with all these data flows? All right, and so this tagging and annotation, this creation of smart data leading to intelligent data understanding actually helps us to manage this incredible flood of data that's coming into our applications, our AI and machine learning applications. We're trying to identify and make sense, that is, characterize and make sense of these data so that we can respond to them, take the right action in the right time, in the right context. So there's data, as we know, from all sorts of sources, industrial applications, right? Web analytics, and many more, health alerts, tsunami alerts, cybersecurity, social events, preventive fraud in finance, predictive maintenance in manufacturing or machines or jet engines or whatever. There's data everywhere that are informing actions and decisions. And if we can't get access to data, if we can't search and find the critical data we need in a particular moment, then what good is it? So we have all this data, and again, not just one and done. We want to reuse that data to create additional value, as Jeff Bezos was saying. We want to create more value than what we're consuming. We want to create something out of this. And so if we can achieve that, we can start looking at all these different applications, even on the screen, that maybe even one in the same data set. Maybe it's the weather, or maybe it's the economic condition of the country, or it's maybe there's something that's common to all these applications. Maybe not, but maybe there is. And you can start collecting the data from different sources to inform contextual data understanding and contextual decision making in all these applications you see here. So I like to tell people that AI is really misnamed. It's called artificial intelligence. And I tell people all the time, there's nothing artificial about AI. I mean, it's got real outcomes. It's got real benefits. It's got real value. There are real applications. And those real things are taking data to insights, to action, and ultimately that business value. And that's what we want to think about. We're not creating artificial value. We're creating real value. So calling it artificial intelligence is I don't really like that. I like to prefer to call it actionable intelligence. And so that comes by bringing data to action. So there's three broad categories of these applications in typical organizations. And these are just broad categories. They capture an awful lot underneath each one of these. And I'm going to cover these in the next couple of moments here. So the three are image understanding, language understanding, and context understanding. So if you want to think about it, just think about the five senses in a typical human being, right? A typical animal, a typical living being has typically five senses. Sight, you can see, you can hear, taste, smell, touch. Well, we don't have AIs too much yet for taste and smell and touch, but we're getting there. So sight, image understanding, hearing, language understanding, and then when we put all the things together, that's context understanding. So maybe it is about touch and smell and other things also. So the full contextual understanding of your environment, which comes from image and sound, touch and smell and feel, all these things come also in a way of helping us to make better decisions. So context understanding basically enables that next best decision and next best action, not just for human beings, but for the AIs that we're building. So the four examples I want to get, I'm going to call it smart data. So you'll see what I mean by smart data. Smart data is data that's tagged and annotated and labeled. And you can collect those things. And I'll tell you again, and as I said before, and I'll say it at the end, if you use it like a graph database, where you basically say a particular data granule is a node, and there's an edge on that says it has this particular metadata property, that is this particular context, or this particular time of day, or this particular location where the data was collected, or this particular use case that it was used for, this particular business unit that used this data. Okay, so if we create these annotations and tags and sort of basically semantic labels that say what is this and why is this and when is this and what is the meaning of this, that creates that intelligent data understanding. But to get to that point, we have to extract the smart data from things. And so just like I said on the previous slide, we have image understanding, language understanding, and context understanding. So I'm going to give these four quick examples here of images, text, multiple sensors, and the Internet of Things. So in images, it's going to be an example of hierarchical segmentation and scene labeling. In text, it's going to be this textual extract, transform, and load. So think about normal database extract, transform, and load. But how do you do that with unstructured text? Well, we'll see an example of that. Multiple sensors. So when we have all these different sensors giving us information, let's say about a customer or about an event, like a sporting event or like the weather, we can start linking and connecting those dots, connecting those different sources of information about that one thing, about that one customer, about that one manufacturing plant, or this one product in your e-commerce store, or this one process in your business. Start connecting the different pieces of information through a linked knowledge graph and actually create more value, which helps to make that better decision because it's going to be a context-based decision. And then ultimately get to this thing, which is going to take over the world in the next 10 to 30 years, which is the Internet of Things. We used to think the internet was a thing. Well, now things are going to be the internet, right? So sensors everywhere is going to give us content and context and even system state tagging. So the streams of data coming from these sensors gives us essentially a state picture. What is the state of this environment? What's the state of this customer? What's the state of this market? What's the state of my manufacturing plant? What's the state of this process? So we get content, context, and system state tagging. That ultimately, and not just enables an internet of things, but an internet of context, an internet of insights. So basically delivering insights as a service and smart data as a service. So like they said in The Wizard of Oz, labels and tags and annotations. Oh my. I see you're smiling there. Labels and tags and annotations. Oh my. I need to make a movie about this. Okay, so first, image understandings. So this is an example from my days at NASA 20 plus years ago. So the scientist there had this really clever idea that there's just tons of data flowing from satellites down to the ground stations and then ultimately into the science data repositories at NASA and the National Weather Service and places like that. And so this data comes from satellites in image form and radar and LiDAR and many different forms. But think about images for initially. So there's just tons of images. I mean, petabytes of images. And I always like to say that data behaves basically like Newton's laws of motion, right? Objects that are in motion remain in motion. People and not people. Data at rest remains at rest. And that is, once you collect that data, store it on a spinning disk somewhere in a data center, it takes a lot of effort and time and resources to get it back off and do something with it. What if you just, as you're downloading that data, downlinking it from the satellite or downlinking it from wherever your data source is, why don't you apply some machine learning in transit while it's in motion? It's already in motion. Yeah, while it's in motion, you might as well just, it's moving through the wire, so to speak, from sensor to your data center. Why not do something as it's in motion? And so he decided he would do basically a Bayesian analysis. So basically he did a labeling of each pixel in images to classify that. And so if you can read the small print there, there's different ways he labeled it using basically a Bayesian classification algorithm using supervised learning of previous scenes. He's able to label things like cloud or desert, land or water, or coastline, or glint, which is just sunlight, which is that yellow thing, just reflected light in the optics. Or maybe it's ice cover. And so each pixel is labeled. And the reason this is going to be done is because most of these images, in fact, you can only do this because most of these images are hyperspectral. It's not just a black and white image. They have multiple colors. And as you can see in the frequency histograms, these different types of features on the ground have different spectral shapes. And so it's possible to give a Bayesian classification to each pixel. So why would you do that? Well, first of all, one reason you want to do it is while it's in motion. That is, as long as you're processing the data and doing things with the data before you deposit it statically in a data center, do these types of classifications. Then what you can do after that is you basically store those particular values, so store those particular labels that you just extracted through this Bayesian classification. And maybe it's not just individual pixels you're storing, but maybe scenes or regions of an image. So if you take an image and subset it, so maybe one big image and you subset it into like a 5x10, let's say. So you have 50 subsets of an image. And those 50 subsets, you basically see what's the predominant classification in that scene. It's called a scene. Is it cloud? Is it water? Is it land? Is it ocean? Is it sunlight reflection? That is glint. What is it? Ice cover? What is it? And so now you basically can store those annotations in those labels. And since it's Bayesian, you also have a frequency distribution, a probability distribution of the different classifications. You know that the likelihood that it's each one of those different labels I just mentioned. So you actually have a feature vector, which has the probability that it's one of those 6 things I just talked about. And so now you basically reduced maybe a million by a million or a million by 2 million pixel image, which is like 8 gigabytes or something like that. You reduce that to 10 by 5 scenes with maybe 6 numbers for each. Okay, so you basically reduce billions of numbers to 300 numbers, let's say. And so now people can say who's doing scientific research, whether it's for climate modeling or maybe it's business research. For example, they want to understand logistics for their business, supply chain, what's holding up our supply chain. Is there going to be a delay in the delivery of my products because of the weather or because of this or that? Someone can say, well, bring me up all situations where there was cloud cover, or where there was snow, or where there was ice, or where there was rainfall, or whatever. Or not only that, but find me cases where other things might have happened, like drought or flooding, or some kind of a natural disaster. You can actually search the data just by searching this very small database of tags and annotations without having to unload from the database, extract from the data center, so to speak, not just one multi-gigabyte image, but maybe even hundreds or thousands or millions of gigabyte images. That's virtually impossible. Whereas if you're just extracting a 300 byte data set, you can extract, a million of those, and it's still less than 1 gigabyte. So you can basically extract, 1,000 days of 1,000 different images of all the information you need to find me scenes that have this particular content or this particular context around it. That is, it's next, maybe there's a floodplain next to an area where there was a wildfire the previous season. The previous season, some brush was burned, some trees were burned. So now there's all this runoff because there's no more vegetation to retain the moisture the next time it rains. You get runoff, and then there's a flooded region next season, the next rainy season. And so people can start searching for these types of things in their data just by querying that very small database of semantic meta tags, semantic labels that carry the context and content of the scenes without actually re-downloading all those massive image files. So that's image understanding. That's an example of image understanding where we're creating smart data tags, and it gives us intelligent data understanding about that image. Now let's look at some language understanding. Again, these are just simple examples. You can, there's a lot of examples I could give you. So basically, the language, and whether it's speech or written language, it's unstructured, right? So you can do this with spoken word or written word. So what I'm saying here is applicable to both spoken and written word. So natural language understanding, again, can be applied to in a voice assistant or a chatbot for speech understanding, but also it can be applied to actual documents, right? So you can generate understanding from the words on the page. So that's unstructured data. So you can identify topics. You can do topic modeling, for example. So what is this document about, or what is this person talking about? And not only can you model the topics, but you can see if there's topic drift over time. For example, a sequence of emails or a sequence of business reports. What has changed over the course of time? There's topic drift, or maybe there's topic emergence. All right, so businesses are now talking a lot more about AI than they were 5 years ago, and they probably weren't even talking about it at all 10 years ago. So topic emergence, topic drift, you can do that. You can do sentiment detection, for example, in customer call records or customer posts on social media. And not just sentiment, but their emotion. Not only are they happy with your company or not happy with your company, but it's emotion. Okay, so you can then tag that kind of information so you can search for it again. So not just detect it, but also store it so you can retrieve it later. And that's the whole point of this. If I want to find documents that are talking about a particular topic where there was some negative sentiment, you can do that now. So you can do both content tagging and context tagging and make it all searchable. And not only that, you can do entity identification. That is, who are the people? What's the names of the companies? What is the name of the location? For example, part of the world or a city or a particular location. You can do entity identification and then tagging it. Said, find me all documents that were talking about this particular city or maybe this particular company in that city. But the other cool thing is you can actually do numerical quantity extraction. We think this is trivial, but it's not necessarily trivial. If there's numbers in a document, yeah, you can read it and you see the number, but how do you extract that into a structured database? Okay, so they're talking about all kinds of different numbers in some written article. Normally you have to manually go through and by hand create a data table. Well, that can be done now. So all this is language understanding examples that AI empowers to create more value, that is smart data, to enable intelligent data understanding from a lot of complex unstructured data. And most of the data in the world is unstructured. I'd say something like 80% of the data in the world is unstructured. And you see that little iceberg there. The tip of the iceberg is the structured data, the stuff that's in databases already that's structured. And it's a really cool tool that this guy, Bill Inman, I think some of you probably know Bill Inman if you've been around the data world for a number of years. He's written like a dozen data warehousing books over his career. The latest cool thing he's doing is what he calls textual ETL. So extract, transform, load is common language in the data warehousing world, where you basically do those transformations in data in order to put them into a unified database with a schema and a data model and all that. He's now doing this with text, with documents. So he's actually creating databases from documents. Unbelievable. I mean, just the traditional schema data model type of stuff you expect for structured data, he's able to turn unstructured data into structured data. And that's essentially creating data intelligence, smart data for intelligent data understanding. Next, we have context understanding for multiple sensors. Okay, it's not so much of an example as a couple of philosophical statements I want to make to you. And one of them starts with this quote from Leonardo da Vinci from hundreds of years ago, where he said, "Learn how to see, realize that everything connects to everything else." So whether it's your customers and your business and the environment or the weather or the market trends, all things are all connected. There's ways that things are connected, and when we see those connections, when we connect those dots and recognize those connections in relationships, not just content but context, that gives us insights, discovery. And so not only do we want that, but we want to be able to store that somewhere. And this is where my pitch is for the graph database. Because as Shakespeare said, all the world is a graph. Okay, he actually said all the world is a stage, I get it. But if he was alive today, he would say all the world is a graph. And why? Because graphs are about entities and relationships. Isn't that exactly what a Shakespearean play is about? It's about people, entities, and relationships. And so a graph is a way of storing and expressing what the entities are, the nodes of the graph, and what relationships they have, which are those edges. And the way you store that for reuse, as search and reuse, which is what I'm talking about today, intelligent data understanding, is when you put that into a database that you can search and reuse, you're creating that new value that you want to create in a structured way through just labeling things. That as we see these connections between different customers or different, not just customers, but maybe customers and the products they buy and the locations in the world where they buy it and the times of the year they buy it. So you've got many different types of entities, not just people. Each of the nodes can be completely different types of entities. And the relationships, those edges, express what that relationship is. Customer buys this product. This product is normally sold during the winter. It sells well in New York State because it's a cold, and so it must be some kind of winter gear like skiing or parkas or warm gloves or mittens or something. But anyway, start creating that knowledge graph. The knowledge graph is like the most powerful data structure for data scientists, because all the world is a graph. The natural data structure of the world, I swear, the natural data structure of the world is not rows and columns. It's about entities and relationships. So that brings us to the Internet of Things. And so it's still contextual understanding from multiple sensors, but now we're talking about sensors in the trillions. So the Internet of everything, all right? So we really need to be able to find the contextual value in all these data streaming from these trillions of sensors in the world, massive quantities of data. Now, of course, your organization, your business, your manufacturing plant won't have trillions. You'll have hundreds or maybe thousands even. Just think about all the sensors in your own home. If you have a wearables on your body, for example, measuring your heart rate or other types of sort of health conditions, but also your refrigerator has a sensor, your thermostat is a sensor. You even have sensors outside your doors if you have cameras, security cameras outside your home or inside your home. All those things are sensors. All these particular types of data give you insight and context in order to make better decisions, not just in your home, but in your business and in our world. So when you start making all those connections and relationships between all those different types of data, you get this combinatorial growth of data. And the only way you can really manage that combinatorial growth of smart data, all the edges, all the nodes, all the relationships, is to recognize, is to put that in that graph, because then you'll look at the edges that have the highest strength, what things are most important in that graph. And that helps you to build what I would call the Internet of Context. So that now empowers smart, actionable intelligence everywhere from all this contextual data. So the Internet of Context is how I like to now describe the Internet of Things, because context is king. Because basically our decisions are made not just on content, but on the context of that content. So context is nothing more than just other data about your data, which we call metadata. So back when I was teaching grad students at the university, I taught a graduate course in data science, and I taught them that the three most important things in data are similar to the three most important things in real estate, right? You know what the three most important things in real estate? Location, location, location. So the three most important things in your data are metadata, metadata, metadata. It's about the what, the why, the where, the when. All those different questions are encoded in the metadata. That's that smart, labeled, annotated data again. So Internet of Things will provide a lot of contextual data. So what's going on in the environment when this thing happened, or when this customer made this purchase, or when this engine failed, or when this particular supply chain broke down, or whatever. So really the most important node in your knowledge graph is the contextual data. That's why I say it's the Internet of context. It delivers context as a service, and in fact, insights as a service. All right, so we just rushed through these 4 smart data examples. And the point is that this smart data, that is these annotations and tags that we're collecting, maybe storing in a graph database, and that smart data therefore encodes that it's the representation of what we've accomplished, which is intelligent data understanding. So machine learning models and AI applications are helped through these annotations and tags because it helps these particular labels and annotations, this graph model, if you will, helps us to understand our data better. And not just us, it helps the applications automatically in an autonomous session, in an automated environment. It helps the automated application to understand the data. And that's truly intelligent data understanding. So we can represent that in different ways in our data. I mentioned graph databases. So we're basically talking about this broad and rich data. It's not just the depth of data we have, it's the breadth of information about the data that we have. So it's broad and enriched. So if you're familiar with RDF triple stores, this is just a way of expressing semantic relationships, linked data, graph databases, that context metadata, even the 360 view, like 360 view of the customer, 360 view of the product, 360 view of the process, 360 view of the patient, 360 view of your manufacturing plant, whatever. That's all these other additional data sources. That's what we're collecting. And so what we're collecting is that data, but then you got to think of some way to express it in that graph database. So there's formal ways called ontologies, which expresses relationships. There's also taxonomies, which are class hierarchies. For example, a hurricane is a type of a storm, which is a type of catastrophic weather event, which is probably a consequence of climate change. So you have a hierarchy that is a way you can start thinking about labeling the sort of the categories as well as the semantic meaning of it, which is that ontology. And then there's informal ways that the communities and business units and business users use their data. And so those informal ways that you label it and tag it and talk about it, those are called folksonomies. So maybe that's the more meaningful thing in your business. So you want to find a particular type of customer. Maybe it's you call this customer most favored customer. Okay, so MVC, or most favored, MFC, excuse me, most valued customer, whatever. So you just label it MVC or MFC in your database. Now that doesn't exist anywhere in the world, just in your business. So that's an informal folksonomy. And so you can generate those tags by automated machine learning, or having just the individuals in your business do that. That's called crowdsourcing. The citizen data scientists just do it. Or just watching how people use the data. That's my favorite way to do it. Just watch how people use the data. Which people are using the data? And so once you know which people are using it, you probably have some idea of what business unit, what business application, what business process, is it customer facing or internal, front office, back office? Just those digital breadcrumbs, those user trails that people leave behind, so to speak, when they're querying the databases. Just like Google knows when you do certain searches, it helps you the next time you search again because they know the kind of things you're looking for. So those user trails are invaluable digital breadcrumbs you can collect and store to help you further annotate and enrich and make your data smart. So next to last slide, your 4 steps to intelligent data understanding with smart data to deliver knowledge-driven action, not just data-driven, but knowledge-driven. And that's what we mean by intelligent data and smart data. It's based upon knowledge, not just the data, not the bits and the bytes, but the content and the context of the data. And those 4 steps are: 1, characterize. First, again, think about that stream of images coming from satellites. Okay, characterize and contextualize those patterns and events in the data stream as it's flowing in. Characterize it. That is, put a label on it, put a description on it. Say something about it. Contextualize how, in what time, in what season, what context is it happening. So create those characterizations and contextualizations of the data. Then collect those. Don't just do it, but collect it and curate it. That is, you put those things in some kind of structured form, like a graph database. So it's now cataloged and indexed, which makes it now searchable. So you collect, curate, and catalog each of those characterizations, the labels, tags, and annotations. And then once you have that stuff stored, then even either as a human manually or as an automated process that is an AI or in a machine learning, you can deliver the right data at the right time in the right context to that decision agent. And then once you got that, then decide and act. I mean, those are our 4 steps to achieving success and creating more value than we consume, as Jeff Bezos said earlier on. So that's it. I say thank you. Come for the data, stay for the science. That's my tagline. But I love this quote from Isaac Asimov, who said, the most exciting phrase to hear in science, the one that heralds new discoveries, and maybe this applies, sure, it applies to data science. The most exciting phrase is not eureka, but that's funny. So when you see something funny in your data, that's telling you something. That's value right there. When something weird is happening, something unusual, something interesting, that's funny. So I'm wishing you all many funny encounters with your data. You can download the slide at the link shown there. And I thank you for listening. Thank you, Metchi, for this opportunity. I'm really glad to be here today, and I hope this brought value to your audience.
Thank you so very much, Kirk. This is the inaugural clap since we're in a virtual sort of situation. That was a fantastic presentation. I'm sure the rest of the audience stand with me when they say thank you. That was fantastic. We have a couple of questions. The first one I would say is, I'll start from my experience. All you just said boils down to creating value with data, creating more than you consume, and that one of the key tenets of that is the metadata and the knowledge graph that you build up. That's really fundamentally what's at the heart of Data Yap, right? The platform where it's crowdsourced content curation about the data, the information that already exists. So that ties directly into it. I just wanted to point that out.
Oh, great. Thank you for saying that.
Yes. One of the other questions that we have talks about in terms of in business, we have a lot of projects or data science analytic projects that have a lot of support and INUI behind them when it's launched and the work through, but rarely most of those projects do they make it into productions in terms of the everyday usage in terms of the business or the organization. What are the key reasons for that, and what are some of the things that someone can do if you're a project manager, owner, to ensure that there's actually adaptation of the solution after the work has been done?
Well, I think it's not novel or creative for me to say, but I think agile processes really are critical even in data science. That is, first of all, you collect those end user requirements and really stay true to those. Okay, I call that mission engineering. Like, what is our mission? What are we trying to accomplish with this? And so sometimes I know data science projects sometimes just start, hey, we got all this cool data, let's see if we can do something. And yeah, you can probably do something, and maybe you find some interesting patterns, but it doesn't really apply to the mission of the organization or the mission of the business. And so start with that end in mind. What is the end goal? And then you work back from there. What is it that we need to build to get there? And then you build those incremental, sometimes I just call them proof of concept. And I don't like proof of concept, because a concept can sometimes never make it out of the lab, right? It never makes it out of the sandbox, as we like to say. Rather, you want to create a proof of value. That is, if you have a business that has some kind of an online presence, and which business doesn't, maybe you want to have a recommendation engine. Even if you're not selling anything, you may want to recommend like your white papers or your blogs or your articles. So when people come to your site searching for something, you might say people who looked at this article might also look at this article. So you can do that very small little incremental thing to build some value from your data. That is, how are people using my website? So you have web analytics if you have a website. All right, so build those small proofs of value, and you start building towards those big mission statements, those big mission value creations for the organization. So it's really about start big. I mean, think big, but start small. But there's one extra piece in that, which is the fail fast, the experimentation phase, right? Be willing to fail, because you're going to learn from failures. I think if someone never fails, they never learn, right? So if a child just gets up and walks, they think, oh, this is easy. And then all of a sudden, it's just like first time some people start to drive, and I won't name any people, but sometimes some people, when they first learn to drive, they think this is easy, and then they get too comfortable too fast and forget about how dangerous it is to drive a car, right? so so you want to like take those small steps, learn from those small failures. Not, you don't want to learn from the big failure at the end, right? So you build this project and it's not used, which I think was the impetus for that question, is that you build these things and no one uses it. Well, you build the small thing, and if no one's using the small thing, then why would they use the big thing, right? I mean, if someone invented the wheel and they tried to invent a car immediately, it probably couldn't have succeeded with building a car immediately. They said, well, this is useless. What's the use? There's no point in having a wheel. Well, no, people started with small things like a wheelbarrow. It had one wheel, then a bicycle, two wheels. And then you wanted your children to learn, so you put three wheels and you have a tricycle. So you eventually learned from these smaller increments of how to create the value from the thing that you're working
Right. Yeah, we have another question. But to follow up before I pose the other question, to follow up on what you just said, one other thing I would like to add on that is, even for the small proof of value that you create, is very important to tie to create metrics that tie the value to ROI. That is critical in terms of ensuring that you're showing proof and
on.
it's going to get
Exactly.
picked up afterwards. So our next question is from Steve Mailers, and he asks how to get important policy and programs to accept knowledge-driven data to solve important problems. Too many roadblocks are in place due to politics, climate change, guns, etc. Um, is all this focused on businesses that have lots of money or data and tech, or can this be for other organizations as well?
Well, I mean, I work for Data Prime. We have less than 20 people, and we're creating a lot of value already, I see. So it doesn't have, size is not that significant in terms of how you use it and the value you can get from it. And I think the problem with larger organizations is yes, there's a lot of inertia there, which goes back to Newton's third law, right? There's a lot of motion in a certain direction, and it's hard to get a large corporation or a large business or a large agency to start moving in a different direction, right? I mean, it's just the basic law of physics, right? It's easier to deflect one thing, but you can't deflect a million things without a million times more force, right? And so I go back to this sort of agile process, and that is part of it is demonstrating the value of this. That's why I call it a proof of value. If you can show with a relatively small investment, and I give a whole talk on data stories, data storytelling, and I know you have a session on that today, and I really love data storytelling. I don't have time today, and that's someone else's talk, but I tell these data stories where companies did these small little things, and the value, having that small proof of value, is it starts building advocacy. That you start finding advocates across the organization. They say, wow, I didn't know you could do that with machine learning. I didn't know you could do that with this data. And so instead of trying to build the big thing, you're going to get a lot of resistance probably. But if you build a small thing that brings some value, then you start building advocacy so that now it starts to spread. Then all of a sudden you have advocates in parts of your business you didn't even know were going to support you. All of a sudden you have people supporting you that you didn't even ask them to support you, because they see that value creation. Going back to the Jeff Bezos thing, creating new value gets people on board. And so don't try to build, like, for example, don't build the big battleship and maybe after 20 years you're done and no one wants battleships anymore. If all you need is a rowboat to get across the stream, then just build a rowboat. Okay, so now we get people across the stream more efficiently than we could before, right? So you have these smaller things that get people to say, yeah, this is good, we want to see more of this. And I think that's, yeah, there's all kinds of political issues, and I'm not getting into that, but politics inside of business is probably the most detrimental thing, which comes down to that culture, right? So I always tell people, develop a culture of experimentation. That is, allow people to test things and have quick failures to learn more. And there's a casino in Las Vegas whose motto for their employees is test or get fired, because they have tons of customer data, right? What games do they like to play? What movies do they like to see? What shows do they go to? What food do they like? What times do they like to go to the show? What time do they like to go to the games room? Yeah, they have tons of data. And of course, if you've ever been to Vegas, they want to serve you free drinks. So what kind of drinks does this person like? Orange juice or Bloody Marys? I don't know. Anyway, so they collect tons of data. From that, they learn how to make that customer experience the best it can be. And so they say to their employees, test or get fired. That is experiment. Find out what works, what makes this customer happy, what delights that customer. And so find those places where you can create delight with data experiences. And I think you're going to find more people getting on board with it.
Right. I think we have time for one last question. And that is, you've talked to us about how to create actionable intelligence, whether it's using image understanding, language understanding, or context understanding. Imagine if you're an organization and you have data, you have image, language, and data, and you have a small project that you're trying to create a proof of value for, right? Um, which one do you start with? Do you start with the image? Do you start with the textual? Do you start with something that's more contextual if it's driving towards the same sort of metrics?
Well, okay, first it has to do with what your business is doing, first of all. And also what kind of data does your business collect? I mean, a lot of businesses don't collect imaging data, but most businesses do collect some kind of textual data, even if you're just watching social networks and what are the customers saying about my products, right? What kind of reviews am I getting on the e-commerce store? All right, so you can do language understanding pretty much right away. And the fast and nice thing about this is if you can actually create a chatbot right out of the gate, basically. One way you can do this is you can use a cloud service, and a lot of the major company cloud service providers have machine learning as an API, and so you actually can have a chatbot as an API. So you don't even have to build it. You don't have to build it; it's already there. You just subscribe to it. And so what the chatbot needs, it needs training data. So the very first thing you can provide is your FAQs, your company FAQs, the frequently asked questions. So hopefully you have some of those that people frequently ask, because otherwise you're draining your business by answering the same questions on the call center phone all the time. So you can put those FAQs as the training data into that chatbot, and within a matter of minutes, you now have a voice assistant. When your customers call, they can get their like 80 to 90% of all their questions answered automatically by a chatbot, and free up your people to do other things. And so language understanding, both in that context as a chatbot, but also in the context of just understanding what people are saying about your business, what the market is doing, what are the market trends in my particular market area. These types of things can bring immediate value. Now, image understanding, again, specifically if you have a lot of imagery or videos or something in your business, then yeah, you want to move towards that thing. But I think context understanding is just really truly the broader umbrella of everything, because context is really just other data about all your data. So all of the things I've talked about really come in the, and under the umbrella of context understanding. But start thinking about how things are connected. So this is the new thing that I think has happened in the big data analytics world of businesses, is that all the different business units are now sharing data. It didn't used to be that way. There were separate databases in HR and customer sales, and product return and all these different parts of the business, the marketing, the business development, they all had their own data sources. But by combining those and integrating those, you're basically that's creating is contextual awareness, right? Connecting the dots across the business units. So I say, if you're not doing anything about language or image understanding, at least try to integrate the data sources you have across all of your business.
Very well said. Well, thank you again, Dr. Borne. That was fantastic. We've had a great time listening about intelligent data understanding for smarter AI. And we've all left with the message that we want to create more value than we consume.
Well, thank you, Metchi. Congratulations to you on what you're doing today. This is really fantastic, and wish you a very successful day. I have to bail out early because we got a big family celebration this afternoon. I do have to leave, unfortunately, but best wishes.
No, it was a pleasure having you. We thank you again.
All right.
For the rest of the attendees, our next session starts at 12, where we will have a hands-on workshop on telling stories with data with Rebecca Pope. We have data privacy fundamentals and challenges of data analytics and AI with Debbie Reynolds, the data diva, as well as a presentation tools enabling data science with Dr. Troy Hernandez. Thank you all, guys, and I will see you at 12. Bye.